couple of questions on access to digital pathology, phrased in various ways, but essentially, how do we ensure that this technology is available to health economies perhaps not advanced as the UK, considering that there's obviously quite a bit of investment that's needed in order to digitize a cellular pathology workload, as even before you can do anything with AI in any case. So anyone want to take up the baton for third world and digital pathology and how we achieve that? Where's
Maybe I can take a stab at that, David, because we do get those requests from India and Africa, for example. And I think the goal is to make sure that they have access to digitization. So there's a lot of vendors out there that have these step-in model scanners. And I think the goal for us at Philips is to make sure that we make that accessible to them and that it can integrate into a network. Like I said, to go to a cloud-based solution there would be really, really appealing instead of trying to send slides across the world, right? So I think that's our goal, to make sure that this becomes a solution that everybody can enjoy, and then connect the expertise. And it's not just the digitizing of the slide, but it's also, I think, connecting to some experts. And so doing secondary reading or expert reading, I think is part of this pathology, like network pathology vision. So yeah, we get this request all the time. We have, for instance, to partner with a company like Objective Imaging and make a step-in model slide scanner that connects to our IMS. And I think we need to see more of that, because indeed we need to get everybody on this bandwagon to go digital.
Yeah, I quite agree. I think digitization is an important part of the solution in providing access to the expertise, isn't it? And I think we need to focus on that in order to deliver it. There's a question, I think, probably for you, Brandon, about explainability. I rephrase this as explicability today, but apparently explainability is the correct terminology to use here. Is it a requirement for regulatory approval that the AI is explainable, that we know what the AI is doing on these slides or scans that we're submitting?
You mean from the end user's perspective, right?
Yeah.
Not from the regulator's perspective, because under the regulator, we ask for all the engineering and the model description in quite a bit of detail. But from the end user's standpoint, no, there's no requirement for any explainability metrics to be provided. And in fact, some of those showing of those explainability maps, the salience maps in the device, we have really not supported those being given to the end user, because I think that technology or that methodology is still pretty fresh and not so strongly validated. Really, anything that is presented to the end user needs to be validated. So the salience maps, I think, hasn't met that bar of our understanding, but hopefully, I mean, we would like to see some of those tools. Certainly, the idea of the confidence of a score given, that is something definitely we like to see. And I know the salience map has that feel, but still there's just so much uncertainty with the models so far. But definitely the confidence of a score is so important, especially when you have a categorical decision. The model is going to spit out one of those categories. And I mean, it doesn't matter what the input image is, it's going to spit out something. And so to have that confidence score, I think, is really important as in a scientific way, as well as any regulatory need.
Thank you for that. There's a question, I think, probably for you, Patricia, on immuno. Would immuno be more specific? I think in this detection of low-grade carcinoma in prostate core biopsies, obviously, than AI. So in other words, do you think AI AI is going to replace the need for immuno in a lot of these cases, or stimulate more immunocytochemistry being done where it might not otherwise have been before? What do you think?
Yeah, I think it's a valid question, because that's what pathologists know when they need additional evidence potentially to establish a diagnosis. So there are a few challenges with immuno that everybody knows. It's sometimes difficult to interpret. On small foci, the focus may be lost, and so it might not actually highlight what you're looking for. And of course, it's costly. That doesn't mean there's not a role for it, even with the use of an AI tool. And I think, again, a little bit comes back to trust. I mean, and algorithmic vigilance, that's developed. And I should have emphasized in my talk, it can be established with a lot of information provided to the pathologist, but that's really developed by each individual pathologist using the tool. And it can be developed, for instance, by potentially that pathologist's comfort level evaluating the output of the tool with an additional immuno, even if they feel comfortable, or potentially it's in a confidence score, as Brandon mentioned, that's in between. And so it might be that immunos increase initially for a pathologist, but then as the pathologist develops more confidence and understanding of the tool, it might decrease. It's very variable, and I think it's very difficult to give a solid answer as to whether we think immuno use will go down or go up. But I think it's safe to say I don't think it will fully replace immuno anytime soon, and I think all of these tools are tools for pathologists to use, and they might go up and down with time, with case, and with the pathologist. Complex answer.
Thank you. Thanks very much. That's great. I was actually thinking myself quite a lot recently about how we manage and support pathologists or doctors in general, I suppose, in radiologists and pathologists using AI. There has to be a risk, I think, doesn't there, that we start to de-skill people if they're not being challenged by finding things themselves all the time, or things being presented to them. Is there a risk of that, do you think? And if so, how would we protect against it, I guess, for the future? What do you think for Page prostate then, Patricia? How will you prevent pathologists getting de-skilled if they're using this all the time?
I mean, I think it's a concern that I think we all think about when using sort of any assistance device. Again, even in immuno, it can always become a crutch where we always defer to that tool to be able to help in our diagnosis. And again, all of these tools have pitfalls, even immunos, as I said. I think it really will take us a critical eye into how these tools are incorporated at the training stage, really. And of course, for pathologists who are outside of training, that's a separate question. But in the training stage, it's a balance between exposing new pathologists and in-training pathologists to these tools and exposing them to all the challenges of using them, while also maintaining somewhat of a normal level of training for them, such that dare I say they could function without them if they absolutely had to, because that's really what we want to preserve. So I think it's certainly a challenge and something we have to put our heads together and how to be able to guard against that, because that will certainly not the outcome I think anybody wants.
How about radiology?
David, I was going to say, we have satisfaction of search as a significant problem. And there's a very large number of studies that have shown that if you just take a chest X-ray and you artificially put a tube on it, the number of cancers that are detected goes down. Or if you put a second artificial cancer on it and the radiologist spots one, they are less likely to spot the other. So that is I have to say, I suffer from it. I was brought up to sort of be patted on the head if I got something right throughout my school days, and I've got it big time as far as I can see. I was trained well, like a dog, and I think you'd need to find some way of taking it away, because it's it's a bigger problem for some of us than for others. And I do know, I have to say to myself, I've got this phrase, before you go, in my head. I go, before you go, folk, you know, and then try and look, but sometimes you forget, but it's a problem.
Yeah, I think it is, isn't it? And how do we, the thing which I'm always worried about in this is maintaining performance of these systems over time. We have to, I guess, develop a process that we measure that periodically and ensure that the AI is performing at the level it always has done. I mean, is that a problem, do you think? I mean, presumably being a computer will do the same thing each time. I don't know, but
it's a big problem. It's certainly, I don't know how the FDA are going to handle it, whether they put caveats on it, but certainly as the scanners move from 0.25 to 0.1 of a mil, etc., and use tube modulation, it's going to be a big problem. When I've asked the scientists, they say, well, you just got to go away and get more scans for us at that new level for us to validate it or retrain it. They haven't got an answer to it other than retraining and revalidation. I don't know about digital pathology, and I don't know how the FDA and the MHRA and others are going to handle this by putting caveats on only use this for the following scanners. I don't know.
Does how about Paige, Patricia? Do you have sets of slides you send out to your users to balance and make sure the same results come back each time, or?
I mean, I think one of our main guiding principles is sort of generalizability and making sure that when we create an algorithm that we do so using a wide variety of data sets, and that can mean many things. That can mean balancing on just the staining quality, on the cut quality, and also many other characteristics, and then doing extensive validation studying. And I think really it's not about us sending them slides, it's about their lab sending us slides and seeing their performance on their data and them doing an evaluation. Because ultimately, you know, we're talking about cancer detection now, which could be potentially a straightforward validation, but one day it might be cancer grading, and that really depends on a lot of other factors. So it gets quite complicated, but I think extensive validation and potentially not just once might be the solution, at least one step in the direction.
David, can I just add to this as well, that when we start using AI, we will have quality assurance measures to be implemented with AI as well. Like what we do with us at the moment, when we have EQA scheme, we need to have EQA scheme for AI. So, and something else, for example, we have, as you know, Royal College, you have like 2% audit or 5% audit of the cases. So these cases can be reviewed on a regular basis. So you have, until now, we don't have actually in place, we don't have QA measures, we don't have quality assurance measures. I think we need this. The more we are moving to routine practice, the more we need guidelines, the more we need to how to use it, guidelines, and the QA measures for AI.
Yeah, I think I agree, Imad. We'll be needing to set up new schemes to cover this, won't we, and include it, I guess.
I think I just wanted to echo that. I think that's absolutely, I mean, very essential. It's something we don't think about, and really, as I illustrated in one slide, could easily cause a performance failure for a pathologist or an AI. But there could be instances where it just causes a failure in an AI, and a pathologist looking at the slide might think the slide is acceptable. Computers and AI take things very literally and notice all the little flaws, and I think it's an important way to study error modes in these tools.
Can I ask you, Patricia, regarding your experience with this? We, as a pathologist, we have a proportion of cases we cannot make a diagnosis. So we take it to our colleague, we see that we don't know, they are difficult for us, either request extra, request immuno, request. What about AI? Because what I understand from most of the presentation in the, generally, they have either black or white. But we are not black and white. We have usually gray zone where we have the difficulty. So how can you address this?
Yeah, I mean, I think AI does not have gray zones, but to Brandon's comment, there are confidence scores that can begin to kind of approach this aspect. And I don't think there's an easy answer, because I mean, when you think of training a solution or a product, you have to feed it data to be able to accomplish that task. And setting ground truth, not something we haven't really touched on, is a tricky aspect. And if you feed it data that is equally in the gray zone, the output potentially might be more gray zone, unless you potentially flood it with data and it finds something that a pathologist can't look at. So I think there are significant challenges with those kinds of situations. And potentially right now, that might not be an appropriate first step for AI to attempt, and will always make us very valuable as pathologists, because we can really appreciate nuance in a way really that at the moment computers have trouble with, potentially.
I'll add something if you don't mind. My niche really is about truthing, especially truthing with expert readers and pathologists or radiologists. You know, I think a lot of the work out there in the field is not spending enough effort on establishing the ground truth. You know, you have one pathologist or one radiologist or two, and then someone who arbitrates between those two. That just isn't enough, given how much variability we know is there with the clinicians. And I understand that there's a lot of techniques for taking noisy labels and using them to still create an algorithm that functions well. But I think, you know, there have to be some subsets of data where the effort is larger in getting the ground truth to be more reliable. And in my work, it's about collecting multiple annotations from multiple readers on the exact same piece of tissue, so that we can understand that variability. And I'm not actually a fan of a consensus result that is one number. I prefer to think of each one of those noisy pathologists as a noisy realization of truth, and trying to account for that variability in the performance results. And that could be one strategy, is to use each pathologist as truth and create your performance, and then see the variability across your truthers. All those things are part of the research program that I'm part of, and really the project I mentioned at the end of my talk.
Okay, that's interesting. So each point is valid, I guess. That's the real world data, isn't it? That each view is a correct data point, and even with a consensus, you still need to factor in the background views.
And I'll say that when we get into meetings within manufacturers, a large portion of our discussion is about the reference method, and linking that to the current clinical practice. You know, what can pathologists or radiologists do, and what is the best way? And it's never to ignore data. It's all about trying to get the best reference standard possible.
Interesting. Thanks for that.
Can I ask Brendan, this is important because it is related to pathology, histopathology. We run EQO schemes, and we know that hardly we have 100% agreement. So, for example, in the UK, we have 800 pathologists reporting one single glass slides. We consider very, very high agreement if it is more than 90%. So you still have 10% of the pathologists to give it a different diagnosis. How do you accept this if we are translating this into AI? So should AI call it 90%, or should we give consider the 10%? How do you consider the 10%? So it is a histopathology is not all the time black and white. It is a lot of grays and a lot of difference in opinion. So how do you consider this for?
Well, I'm not exactly sure how to answer that, except to say, you know, you have to convince, at the FDA, you have to convince a clinician and a statistician, and maybe someone like me who's a little bit more on the methodologies in the algorithm space. But, you know, you have to convince your peers that your reference standard is strong enough. And if you can't convince your peers, you're going to have a hard time convincing the FDA. Because the FDA is nothing more than the outside world, just at a different address and building. So we do have a lot of variability in opinions, and we try real hard to come to a final decision that represents the risk and the benefits of making the decision, as well as the evidence in front of us. So, so that's my quick answer to that.
Okay, thank you. So I've got a question here about using this data for research. Do we need consent for this data research? So I know what we do in PathLake. What about NCME, Fergus? Do your patients get consented for the use of data in research?
It depends upon what it is and what the studies are. So it is possible, if you're collecting the data prospectively, to obviously consent patients for its use and explain where it's going to go. If it's lung cancer data that's 3 to 5 years old that's being collected as retrospective data and for pulmonary nodules, then the answer is not. You still need ethical approval, but you don't necessarily need patient consent. I mean, I think David has probably got far more professional expertise than I have on it, but we take advice from our research office and ethicists, etc. But that's how we do it.
David, what do you think?
I mean, I think consent is always going to be a really touchy issue when it comes to using health data. I think that from studies, it's shown that the public is very willing to, even when you start with an opt-out in terms of how their data will be used, they're willing to have their data used for the public benefit with regard to health research. After all, it's largely going to be de-identified, and it's not going to pose the same sorts of ethical concerns that other forms of personal data do. And at the end of the day, if the research purposes are advancing medicine, it is less likely that there are going to be huge ethical issues there. That being said, I don't think we live in a culture of public trust when it comes to any use of data right now. And that's cause for concern in general, in the sense that even when we see all of these opportunities to capitalize on these new technologies, at the end of the day, we don't live in a structure of equity, a social structure of equity, where people have confidence that their information is going to be used for the benefit of everybody else. So again, there's a complex and ambiguous area that you have to enter into when you think about consent, because it brings us to those kind of wider issues.
Yeah, okay. Thank you. From PathLake's point of view, practice varies across our sites. So some sites do collect consent routinely for data research. Most don't, and we, generally speaking, well, it's all anonymized anyway when it gets used. So generally that satisfies our, well, so far anyway, satisfied our ethics applications from that point of view. But thanks for those points. That was really helpful. A question for you, Fergus. Are there AI tools used in clinical practice in radiology routinely, and are they even recommended in guidelines? So is that the case now in radiology? Do you get tools recommended by NICE or whatever?
Okay, so I'm afraid I don't know the whole of the radiological world, so please forgive me if I come across. I'm aware that there's approval for them for mammography, and I'm aware that there is approval for use of them for stroke, etc., in both in the UK and elsewhere for certain instances. They are used routinely. Then it depends on where you put your threshold for what is artificial intelligence and true deep learning, but they are used and recommended in lung cancer screening now for detection of pulmonary nodules, because there's a fair amount of evidence to show they're better overall at detecting nodules than humans are, although they do miss nodules adjacent to the hilar and endobronchial nodules. So yes, there are some in clinical practice, and I know NICE is looking at them. What we don't have, as far as I'm aware, is guidelines on training to use them. I know the manufacturers go, but actually I don't think there is. As you may have gathered from my talk, my concerns are that these things aren't ready quite yet, but when they are ready, we've got to make sure that we use them in the right patients, in the right way, and the right people use them. And I just don't think people understand that. I think we might all understand that, and the scientific community might understand that. But I did see that the Secretary of State for Health said that the productivity was going to improve by 30% over the next number of years because of the use of artificial intelligence. And I thought, oh, well, he's reading things I'm not reading.
Maybe you're seeing some of my slides, I don't know. Okay, thanks. So some other questions that have come in. Question about whether there's any open source software for annotation produced by Pathlake or NPIC. That's our companion centre in Leeds for digitisation of the rest of the world. The Pathlake annotation tool is built on open source tools. We've changed it quite a bit actually, but we will try and make it available in the future. I don't think it's available just yet for everyone else to use, but we are hopeful we'll be able to do that at some point in the near future. I don't know if NPIC has got anything or not, I'm afraid. So I had a question actually for you, Phil, about natural language processing, and how widely is this used now across the UK in hospitals for scrutineering of records?
So
is it a complex or?
It's the honest answer is probably not actually here in the UK. I think NLP for the use of reporting, in cancer cases is you could almost look at it as low-hanging fruit for the use of artificial intelligence within healthcare, because actually in the use of cancer reporting, you're not directly impacting patient outcomes potentially. So in a sense, it does give the opportunity of providing those increased efficiencies whilst reducing potential patient risk. Now, you clearly do have the same challenges that were mentioned earlier around potential bias that could be incorporated into that, especially if you're using clinical notes. But if what we're talking about is absolute extracted data for reporting purposes, then I think that's why, certainly from our perspective at Inspirato, we do view this as a good opportunity to start the use of artificial intelligence in a broader scale, and start to build that confidence level up. In the US comparatively, we work with the National Cancer Institute there, and about 280 hospitals use natural language processing for the purposes of cancer reporting. And actually, as I'm sure you probably know, but the model they operate tends to be quite different as well, in that there'll be a cancer registrar that will be discerning whether a case is cancerous or not, and then reporting that case. And NLP is actually being used to determine whether a case is cancerous or not, and therefore whether it needs to be reported or not. And I'd say we're a little ways behind that. I know anecdotally from talking to a number of trusts the challenges in and around COSD, for example, reporting in that sense, and actually you could argue that's a great use case for NLP, which we do try and argue quite strongly where we can. But I think it's safe to say that we're still at an early stage here in the UK.
Yeah.
It's certainly been my view and my experience.
And in the US, is it widely used to sort of summarize case records across electronic patient record systems? Is that?
Yes, yeah. So in a sense, and again, to give a big leg up that the US has is this use of the kind of monolithic EMR EHR that we don't necessarily have here in the UK. We all know that, but in the instance of Epic, for example, one of our tools is there and available on the Epic App Orchard. And so if a clinician decides that they want to use it, it's not quite as straightforward as, you know, your app on your iPhone, but, you know, the idea is it becomes this more consumable type product. And if you're using Beaker in the Epic environment, you've got an embedded solution that applies NLP to amalgamate various elements of the clinical process via unstructured data. And then you're able to use that unstructured data to make these or provide clinical decision support, for example, in the case of clinical trials. So I think just, and again, I think we've all near enough touched on data being a really critical element, or data sharing being a really critical element to all of this. And the experience in the US, certainly from our point of view, has been that because of the way the systems tend to be a little bit more joined up, that data is a bit readily available to use. And we have a rich tapestry of systems, shall we say, here in the UK, which presents its own unique challenges.
Certainly does. Certainly does, isn't it? Yeah.
I can add something, David, on that one. We do see a need. I think you're right, Phil. The structured data approach in the US is a little bit easier to interpret, but we do see a need in these multidisciplinary settings where they want to see some disconcordance between radiology and pathology. And that's just where NLP really can help to sift through this database of information. And specifically, we saw this with COVID cases, obviously incidental findings for lung that were not followed up on. And then you can use these kind of tools to kind of find those needles in haystacks and pick out those patients and indeed follow up. So there is, I think, a trend going on to use it for that purpose. And then obviously you bring it, hopefully, in an earlier stage to act on. So that's really, I think, beneficial.
I mean, it's quite a headache, isn't it? Because we routinely looking at 3 different hospital systems in where I report in Coventry. You've got hospitals to the north and south that's feeding into us, and you're constantly looking at other EPR systems to find out what this patient's had before. A system that could kind of summarize that for you in advance would be really, really useful, actually. And it would mean things wouldn't get missed as occasionally, sadly, they do. Otherwise, you get buried and overlooked, and the obvious is not thought of. But, yeah.
I think just to add, David, as well, part of the benefit of using something like NLP, just because of the nature that actually you don't necessarily need this deep integration that you may need in another system. If you can get a feed out of the system that's HL7, for example, actually you can just apply NLP straight to that raw feed, and it will start working for you, and then it's an iterative process. So it's funny because contrary to what I've just said about the use in the US being beneficial in the sense that, or larger uptake because of these centralized EMRs that you have, you could argue that the actual use case here in the UK is stronger because we have such decentralized data or availability of data.
Yeah. Okay, so as we move over to AI and start using it everywhere, is the network going to cope, do you think? Are we all going to come crashing down when we try and shift gigabytes of data across, to the cloud and back again all the time, day in, day out? It's not going to meltdown, isn't it? I mean, one scanner and the place fell apart already, didn't it? So how are you going to manage with running 5 AI programs?
We get these requests all the time, and if you look at the business case, indeed, of all the data that's now being aggregated, actually the cost of storage is dwarfing the cost of the scanner and an image management system. And so I think this move to cloud-based storage is just going to have to happen. Otherwise, it's just too expensive. But then you get all the other questions, right? Which is, how do you retrieve the data? At what point in time do you retrieve the data? So Amazon and obviously Microsoft have these, deep glacier storage capabilities, which are very cheap to store data in. But if you want to pull them out, the bill is going through the roof. So smart, technology and maybe even AI to recognize that is going to be necessary to make it really part of the workflow. So I see that the capacity for storage across the world, if we really want to scale this up, is going to be a big headache for health systems. And so there has to be some sort of a smart cloud approach. And yeah, we need to work with these vendors to address this, because it's just astronomical just already now. So if we see this for the future, this is going to be a headache.
Yeah, I mean, I think it's. I mean, presumably, Fergus, in radiology, the technology, AI, as it were, is sitting on your on premise on your workstations. You're not using cloud supply for it, are you?
No, some of them are. The majority of them will. There's all sorts of issues. There's how you're going to make it carbon neutral, and the second of which is, you know, some of them want to charge you $10 a pop, and some of them want to charge you $60 a pop per scan. You know, that's gonna. I mean, we do millions of examinations a year in the Oxford, and then maybe tens of millions in the Thames Valley in the NCME network. You know, someone has got to show that actually, if you take, there are 1 million pulmonary nodule scans a year in the UK. I think, you know, we're paying $60 a pop for that. No one's paying for it now. Someone's going to have to say that it's actually, that's money well spent, and also that actually it's carbon neutral, because I can tell you it's not carbon neutral. It's very, very carbon intensive.
Yeah, I would, if I could add to that, Fergus, to just say that there are two really sort of important ethical issues here. One is, as you mentioned, this idea of environmental impact, which is to say, do we really understand the kind of high cost of compute when it comes to, you know, the ways in which our practices will impact planetary health, whether that's in medicine or in, you know, autonomous vehicles. I mean, there will be high processing need, which will have cost on the environmental side. The other bit to follow on with what you're saying is the centralization of power and extraction of value from the kind of shared economy, which is to say, when you've got compute infrastructure and data infrastructure that's increasingly centralized and provided by private companies, then ultimately there are equity issues that will ultimately arise, even if we're trying to do good through cloud storage, cloud computing. There will be an extractive dimension which will cause inequality and increase inequities that will manifest in medicine. And so this is something we really do need to be aware of, that infrastructure itself, critical digital infrastructure, is something that needs to be treated increasingly as a public good, and it's on us all to recognize that and to push back when we are being demanded to pay these high costs for our computing.
But hang on just a second. It's very expensive to develop these algorithms, and you know, as far as I know, that there aren't many being developed behind the X-iron curtain. So you know, the companies, they have to make their money somehow, you know. So I love this idea that actually it's very expensive, so we want to pay less. I know it's cost you. If you look at the Optellum thing or the other stuff I'm involved in, 7 to 15 years, 100,000 pulmonary nodules, 12 countries. You know, I do laugh when NHSX, I got an email from them today. I hope maybe they're listening, that could I provide them with 600 extra minutes of my time over the next month? You know, none of that is included in the costs. So all of they're very expensive. Someone has to pay. They need to prove benefit, and we do need to do carbon neutral, but someone's got to pay.
I mean, I would say I think there's a public utility argument to be made in some sense for the provision of digital infrastructure, and in the sense that, yes, someone has to pay and someone will benefit, but there are constraints that we really need to consider in terms of the scale of redistribution that happens as a result of the high entry costs of, you know, building these forms of infrastructure. So I think that, yeah, but I agree, it's complicated.
Okay. there's so a couple more questions just come in actually. One was about triaging. Should we use AI for triaging normal versus abnormal? And is that a helpful thing for us to be doing? I guess it is kind of helpful, isn't it, to have abnormal cases pushed forward to the front of the queue? What's the panel think?
Can I say, I think in radiology, it in part depends upon where the front of the queue is in relation to everything else. And the second thing is who's going to take liability for someone having a tension pneumothorax put to the bottom of the queue because the algorithm got it wrong because the chest X-ray was of poor quality in an obese rotated patient. So, I mean, I got an email, you know, from one of the clinical directors saying, "Dear Fergus, I was asked to review the CT pulmonary angiogram when you said there was no pulmonary embolus. The present died later that night." That was the start of the email. Fortunately, she said, "I agree with your report." But imagine if the algorithm had said, "Dear Fergus, I put this one to the bottom of the pile because I thought it was normal. The patient died later that night." You know, I mean, it's not as straightforward as is being suggested. That's I think. Right. I don't know about pathology, but in radiology, it's and we don't use the humans well enough. We don't use the radiographers, the technicians well enough. They're not well enough trained so that they can act as the first go. Maybe algorithm second, radiologists that I don't know.
Completely. Go ahead, Dr. Sneed.
No, I think that's right. You've got to think. It's important to think these things through because there are unintended consequences quite often with these kind of developments. Sorry, Patricia.
No, not at all. I was going to add, I think a lot of it also depends on how the tool was designed. I mean, every tool has a trade-off between sensitivity and specificity of detection. So is it great at finding the positives and it will never miss one? Or is it great at finding the negatives and it will sometimes miss? I mean, it's always a trade-off and potentially a more although useful for triaging. I mean, triaging is a way to capture efficiency early on, especially in pathology where we have to order stains and get a case going potentially earlier in a day based on practical cutoffs of the lab. A potential future might be where an AI not just incorporates the results on the slide, but again, maybe incorporates some information from the EMR so that if there's a high discordance between the AI predicting something as negative, but the EMR says pancreatic mass, that is really a point where a human provides critical insight into this doesn't make sense. That's where I should go first, potentially. Food for thought and potentially years down the road, but thinking about really possibilities of tools like this.
Absolutely agree. Yeah, absolutely agree.
Can I add that I just want everyone to put in their brain that triaging should only be done when the treatment is a time critical situation. Because I feel like triaging is coming into situations where that's not the case. And so it's really not providing a real value to the patient when it's something that has more time to react and the clinician is going to get to it. And so I feel like triaging is kind of the low bar approach to get on the market in some areas. I'm not saying it's profound or pervasive, but you know, spend your time on making the algorithm provide that clinical advantage rather than just to get onto the market with a low bar, which triaging, the arguments can be made that all we're doing is reordering the patient. So what's the risk there? So, but the benefit has to be there. I mean, that's the risk benefit trade-off.
That's a really good point. Thanks, Brandon. Yeah, really good point. Okay. Just a question for you, Ardi, about your DID tool. Does that adhere to GDPR and HIPAA compliance? In radiology and pathology. So you have a similar tool in radiology, is that right?
Yeah, yeah, we have to, otherwise you can't use the data. So we have to make sure that it's completely anonymized and de-identified. So otherwise yeah, like I said, unusable data, and it keeps keeps us on our toes too, because we have to continuously check and verify. So this is not a static process. So we've continuously make sure that is attained.
Okay.
You know, if I could add, you know, there's training for the clinicians needed for this de-identification business, because you'll find patient information in the strangest places, and if the community could agree to not do that, it would simplify some of those de-identification methods. But you know, whether it's putting it in the descriptive report, something that is a patient identifier, I think everybody needs training to get better and better at creating data that easily is de-identified.
Yeah, it's a good point, Brandon. So this is not just a technical exercise, right? This is also a service offering. So we basically provide, skill set and knowledge training about what can you indeed de-identify. And some basic things are overseen. Dates and linked to ages or something like that already can be very sensitive. So yeah, it needs to be part of the service.
Your tool can strip all that out there, Phil, presumably.
Yeah, I was literally about to say. So, again, it's another one of these use cases for NLP. But rather than extracting the data, the NLP, as long as the algorithm you've got has the ability to detect, what is a person's name, what is a date, then it can strip it out. But it's funny enough, we've got into discussions with trusts, and they've wanted to run some data, but obviously they have the challenge of they can't share that data because it needs to be de-identified. So we actually have to then install our products so they can de-identify it, so we can show them of what we can do. So yeah, I mean, it's another kind of simple use case, but one that can add real value and facilitate and accelerate the uses of AI further as well.
David,
Okay.
David, I think we finished. We need to close.
Yeah, I think we need to wrap up. Well, just leaves me to say thank you very much to all the presenters for a very stimulating set of talks and your contributions throughout the afternoon. Thank you very much, and thank you to the audience for being with us and for posing such challenging questions. I think it's been a very, very interesting session. So thank you all very much.
Thank you for asking us. I enjoyed your talk.
Thank you.
Bye-bye.
Nice.
Thank you.
All right.